Hello, grade 10s. In this video, we are going to be covering how to write your formulas as well as how to name your compounds. So I need you to go to page 2 of your notes. I want you to think back to chemical bonding as well as atomic structure when we spoke about charges or oxidation states of different elements, as well as how different elements bond together. So ionic bonds are what? The electrostatic attraction between a positive ion and the negative ion. What is a covalent bond? A covalent bond is the sharing of electrons. So just keep that in mind while we are working through these formulas. There's a little trick or a little method that I'm going to show you today. It's called the swap and drop when it comes to charges. So I want you to, this is a nice way to predict the actual chemical formula of your compound. So let's look at, on the left-hand side, there's a little column there. There are three different compounds. You've got some hydrogen carbonate, and some magnesium, and the first one. So if you look at magnesium is in column 2 of your periodic table. Therefore, it tends to form a +2 ion. And then you have carbonic or hydrogen carbonate, which is going to form a -1 ion. When these two are bonded together, to make sure that they are neutralized, to make sure that they are stable, okay, the charges need to cancel out. There needs to be zeroing. There needs to be equilibrium. So what we do is we swap the charges, and then that can protect our chemical formula. So we have swapped the +2 to the carbonate, and we have swapped the -1 to the magnesium. Therefore, our formula is going to be Mg, and in your little brackets, you're going to have HCO3, and it's going to be 2. Okay, so therefore, it's nicely, I would need 2 carbonates or two hydrogen carbonates to balance out the magnesium ion. Let's look at the second one. You've got barium nitrate there. Therefore, barium is also in group 2. It's going to form a +2 ion, and the nitrate is going to be -1. To cancel out, you're going to have to swap the 2. You're going to have 2 nitrates. Therefore, it's going to be Ba, and in brackets, NO3 with a little 2 at the bottom. So that whatever's in the brackets, okay, that little 2 relates to what's in the brackets, not to the barium. It's only the little brackets. The last one I have got there is potassium nitrate. There I've got potassium, it forms a +1 ion, and your nitrate is -1. We've dealt with them all the way through. They zero out, they cancel each other out nicely. So you're going to have a compound that doesn't require any sort of brackets. It doesn't require any extra charge or extra atoms added. Now I want you to have a look at on page 2. You will see that there are five compounds there. Let's look at a few of these compounds. The first one is lithium oxide. How are we going to write this? Let's see. Lithium oxide is going to be written as Li2O. Why? Because oxygen forms a 2 negative ion. Okay, it forms that 2 negative anion. So I would need 2 lithiums to cancel out the oxygen. Hydrogen iodide, okay, right, I don't need anything extra, just HI. Okay, that is all that is required for that one. Magnesium bromide. In this case, I need 2 bromines to cancel out the magnesium charge of 2+. Aluminum oxide, here, this is interesting here because aluminum is in my +3, oxygen is in my -2. So to make sure that they are 6 and 6, I would need 2 aluminums and 3 oxygens. Hydrogen sulfide is going to just be H2S. So please write these in now quickly, and I hope this makes sense. And use the swap and drop method just to quickly write your formula, and you don't have to it's a quick and easy way of getting to an answer without stressing too much. Let's look at our complex polyatomic ions again. Remember from the previous video, we introduced them when we were talking about exchange reactions, and we're talking about single and double replacement reactions. They are very important. I hope you've all written them in on page 2. You need to know these very, very well. And the charge is exceptionally important. Okay. We always write these in parentheses or in brackets when bonded to another element like metal, especially if there is we require 2 or more of these polyatomic ions when we are bonded to maybe one atom of metal, okay, or let's just say with the sodium phosphate, there were three atoms of sodium there, and then you have your potassium, which has got a -3 charge. So the -3 and 3 atoms of the sodium, they cancel each other out. Let's look at the other one we've got there. We've got ammonium nitrate. Ammonium has got a charge of +1. Nitrate has got a charge of -1. They cancel each other out beautifully. You don't have to add anything extra. You don't have to add a parentheses around nitrate and add 2 there. We don't require 2 nitrates. And then there's a beautiful new one there that you would have never seen before, that is dichromate. Okay, so there I'm going to have potassium, which is a +2, and my dichromate is going to be a -2. They cancel each other out beautifully. So please just make a note of this. Understand that to create stable and neutrally charged compounds, we have to take into account the charge or the oxidation state of that compound or element. To throw a spanner in the work, we are going to introduce you to a different type of notation. This is called stock notation. Here we use Roman numerals to indicate the charge of your cation, of your metal, specifically your transition metals. So this works with transition metals. So transition metals are very, very shifty characters. They're shifty characters. So they tend to transition in oxidation as well as charge. So oxidation and charge is used interchangeably here, those two terms. And this is related to the number of electrons that an atom loses, gains, or appears to use when joining with another atom in compound. So therefore the charge, okay? So we are confident in the oxidation or the charge of ions of elements in group 1 to 8. Guys, you know your table, you know how it works. However, transition metals are shifty characters and as such can have multiple potential oxidation states. So this is related to the d orbitals, electrons that are unpaired. I'm not going to go into this now. I'm not going to explain the full reasoning why. However, if you want to know and you want a little bit extra, please let me know and I will we'll have a video call or I'll send you some information. The point I'm trying to make is because they move between these different charges, to when you come across a compound with a transition metal, okay, how we figure out how to write that or name that compound based on the formula, okay, is got to do with the charge of the anion. We know what the anion is. We know what that non-metal tends to do. So we can zero it out that way. I'm going to show you examples of this. So, I mean, look at the calcium and oxygen. We know exactly what's happening here. The next one I'm going to work on is going to be mercury and oxygen. And you're going to see how this stock notation works. So at the bottom of the page, it's page 2, you will see there's a little heading for stock notation, and there is the explanation that I've just explained in the previous slide, but now we're going to use mercury. Okay, so we forget about, how do you know about what mercury's charge is? We don't know what mercury's charge is, but it's given you the name of the compound, and it's saying it is mercury 1 oxide. That 1 in Roman numerals means that the mercury has a charge of 1. So when I write out my chemical formula, I know exactly how I'm going to write it if it is paired with Oxygen. Oxygen has got a charge of 2 minus. So because it has a charge of 2 minus, I have to write my mercury 1 oxide. I have to write it as Hg2O for that to be cancelled out and completely neutral. Okay, so to determine what the oxidation number is, you must use the anion to determine what the positive oxidation number is. Or if you are given the actual name of the compound written out in words, whatever's in the Roman numeral is the charge of your cation. So based on everything that we have learned now in the last few slides, I want you guys to go back to page 1. I want you to make sure that you filled in your balancing of equations paragraph with reactants and products. And I want you to check your initial balancing from the first lesson we did. Remember, I told you guys to just balance the equations on the first page. So go and check your initial balancing, and then I want you to write out your word equations based on everything that we have learned. And you'll see that we're using mercury 2 oxide here. Okay, so in this situation here, you can see the subscript of the everything is nicely outlined for you. The subscripts give you indications when you are working with transition metal or with a metal that is got a varied oxidation states. Have a look at how we have written out our polyatomic ions, because that is very important. And then also have a look at how we put these polyatomic ions in parentheses, in brackets, when we've needed more than one to neutralize the charge. So if you go to page 3 of your booklet, you are now, I think, ready to apply all the principles and all the theory that we have gone through in the last few videos. So on page 3, I've written out the first 2 chemical formulas for the written word names of those compounds. So the first one we have is copper 2 nitrate, and we have zinc 2 carbonate. So what I want you to do is actually have a look at how I've written out in chemical formulae. Both cations have a charge of 2+. So as such, we need 2 nitrate ions to stabilize the copper, and only 1 carbonate to stabilize the zinc. So write these in, and then you guys are going to complete the entire page and start working through the equations on page 3. You are going to work on page 3, 4, and 5 in this lesson. Okay, and then in the next lesson, we are going to go through all the answers. Grade 10s, I want you to have a look at these 4 equations that we have in front of you right now. I want you to see if you can actually break this apart. Include the ions, include the how it exchanges, identify the cations and the anions, identify what type of reaction it is if you can, and then take your highlighter or your colored pencils, whatever you are currently using, and just highlight the different phases. Maybe like make sure that like yellows maybe all the solids. Let's have a look. Let's solid over there, and maybe aqueous is going to be light blue. Work on actual provide a little key for yourself. Put this in your notes in the section underneath chemical equations with phases. Put this in your notes as a little extra, and it helped you identify things, because in the exam and in the test, besides the actual balancing, the process of balancing, we might even ask you to identify certain things in your equation, like the cations and the anions. Remember, we spoke about net ionic equations. We might even ask you to do that. So please just, I'm trying to make life as easier for you as possible, or as simple as possible. So if you want, add this to your notes and break it down and actually deconstruct everything and indicate what the arrow means, indicate what the parentheses mean, indicate the coefficients, go wild, because the more information you have and the more detailed your notes are, the better off you're going to be later on when you're applying those notes to the actual applications or the actual problems. On page 5 of your books, you need to write in the abbreviations for each of the different phases. So for solid, I need you to write S. For liquid, I need you to write L. Gas, G, and then aqueous, AQ. Please write that in now. You will see that there are 14 descriptions of reactions, and they actually include the phases in there. Your job is to write out the chemical equation for this using the phases on page, and there's space for this on page 6. So in total, grade 10s, you need to do the chemical formulas on page 3, the equations on page 3, the equations on page 4, the equations on page 5. I do think the equations or the chemical formulas. And then the last thing on page 5 are these descriptions, and they need to be written out as balanced equations, chemical equations on page 6. Okay, so use your time wisely now. This video was very, very short. It was only 16, 17 minutes long, and use the rest of the lesson to complete your work so that you don't have homework. Have a great day further, and don't forget, you can always contact myself or Mr. Ginsberg if you are stuck. And we will see each other soon.